Hello everyone, welcome back to our generative AI series. In the previous video, we understood what LangChain is, why it was created, the problem it was solved, and how it simplifies the development of the LLM applications. But understanding what LangChain is, that is not enough. So in the real world application, we need to understand that what are all the building blocks of the LangChain and how it will make LangChain so powerful. Okay, so how does LangChain connect an LLM with prompts, vector database, or any external APIs or any tools? We have to look into this part as well. So that is exactly we are going to learn in today's session. So we'll explore the core components of the LangChain, what are the responsibility of each component has, and finally how all the components are working together. So we are going to see the working of the LangChain, and that will be a entire LangChain workflow. By the end of this lecture, we'll have a solid understanding of the workflow of the LangChain and we'll be ready to start building a real world application in the upcoming practical sessions. So without any further delay, let's get started. So key components of the LangChain. So now that we understand what LangChain is and why we need it, in the next question is how does LangChain actually works internally? So that answer that is lies in the key components or core components of the LangChain. So each component in a LangChain has a specific responsibilities. Like as we have model, prompts, chains, they'll have some different responsibility. They'll perform different tasks. So few components, they'll go and interact with the large language models, but few components will go and retrieve the information from the external sources. One component is for writing the prompt, or that will help us to manage the prompts, and it will create some conversation history as well, and some perform some actions. So every component have a different responsibilities. Each one will not do the same thing, or they'll not perform the same task. Every component will go and perform some different kind of task. Okay, so together these component form a complete workflow for the large language models powered applications. Okay, so when we'll be using this component, it will create a complete workflow. Okay, so we'll go and understand each component one by one. So these are the major components which we can see in the screen. So first is model, then prompt, then chains, then vector DB, then memory, and at the end we have agents. So these are the main component or major component of the LangChain. So models, what this model is. So this is like large language models. So models are responsible for understanding the user's input. So when we'll be sending the user inputs, according to our prompt, large language models or models will go and do some analysis, or what are the understanding they'll have according to our user input, and they'll generate a response for us. So LangChain itself, only LangChain itself doesn't contain any AI model. Okay, so inside the LangChain we don't have any models. What it will do is it will provide a common interface to interact with different LLMs. So we have different kind of LLMs like as Google Gemini, Open AI GPT, Anthropic Cloud, Hugging Face models, etc. There are many more models are there. Okay, so it will provide a common interface for all the models, so we can use any of the models without changing the without making so many changes in our code. Okay, so these are the models which will be using it over here. So LangChain will help us to provide an interface to use these models. Okay, and now, so LangChain will support here integration with a wide variety of language models. Okay, through a common interface. That's what we discussed just now. Okay, and we can use the API key of any model. So for each as we learned in LLM video, we have so many models, but what are the model we want to use, we have to use the API key of that model, and we'll go and use it. suppose if tomorrow I want to use Google Gemini in place of OpenAI, we can go and change the API key. We can switch one model to another model with a smaller change, with a minimal change in the application. We don't need to go and change everything. All the code changes not needed. We just need to use the LangChain interface for that. Okay, and this is the brain of the application. If we'll see, it mentioned, right, the LLMs that generate responses and reasons over inputs. Okay, so then we'll move forward to the prompts. So prompts, as we already know, prompts are the instruction which we are providing to the LLM models. So if we'll provide a good prompt context, okay, if we are providing a more context to the model, they'll help us to generate a proper response or good response. Okay, so what it will do is, if we'll provide some good prompt or context, it will help the LLM to generate or interpret the input and structured output. If we want in a JSON format or in XML format, we have to give a proper prompt, or we have to provide a proper prompt to the LLM, so it will be able to understand what kind of output we need it. Okay, so it will be very helpful for the LLMs to provide us the response back. What kind of response we wanted, we have to mention it. What kind of data we wanted, we have to write a proper prompt for that. Okay, so in many application we have a dynamic prompt. Okay, we'll see what is the meaning of dynamic prompt here. Okay, so in dynamic prompts there will be some part which is already fixed, we cannot change it. That is a fixed prompt. And few part, or suppose if we have 5 lines, in 5 lines we have 2 lines, that is a dynamic one, but other 3 lines are the fixed lines which we cannot change. Okay, so while others changed based on the user's requirement, so few lines will be changing according to the user's requirement. If we want to change our input, we'll provide the dynamic prompt. So here what is happening is, we are not writing any manual prompt, or we are not concatenating any prompt here. What we are doing is, we are just using the existing prompt templates over here. Okay, so we'll not go and write any string, or we'll not write any prompt and we'll concatenate it. For that we have already prompt template in the LangChain. So prompt template will help us to use the reusable prompts structure. There will be some placeholders which we can use it for our dynamic executions. Okay, for our dynamic data we have to provide it, and when it will be executing, it will take our dynamic data as well. So we have prompt template class in the LangChain, and it will formalize the composition of prompt without the need of any manually hard coded queries and any context. We do not need to write it, just as we use these templates in Java or HTML to avoid some duplication, right? Same way, prompt template is helping us to write the reusable prompts without writing them from the scratch every time. We are not going to writing it, we'll just use the existing templates. Okay, so if we'll see here, it's mentioned, right, templates and instructions that guide the model on what to do and how to respond. Okay, next is chains and or runnables. Chains means most of the AI application involve more than one steps. So if we are developing any AI application, it will just not have only one task. It will perform hundreds of tasks or tens of tasks. It depends on the application what we are creating. Okay, so what we'll do is, instead of writing a separate code base for every step, or we'll connect these steps, LangChain what it will do is, it will allow us to combine multiple operation into a chain. So if we have 7 steps, we'll combine all the 7 step into a single chain over here. Okay, or here the chain is what chain will represent here. So a chain is representing here a sequence of operations where the output of the one step is going for the input of the another one. So first step is like we are providing some input for that. Then from the first step, whatever the output we are getting it, that we are sending to the second step. Okay, so for a dinner vegetable, so first what we'll do is we'll chop the vegetables and then we'll just fry some masalas and all. So these are step by step process we are going to follow it. First we are going to chop it, right? This is a one step. Then we are going to make some masalas over there, and after that we are going to cook the vegetable. So these are the 3 to 4 steps which we are following when we are going to cook a vegetable, right? So same way in the lang chain, okay, what it will do, it will just represent a sequence of operations where the output of the one step is input for the another one. So each step means here, like, is suppose if we have to call a LLM, or we have to do a data retrieval or some other actions, that is the steps in the AI application. Okay, this will help to organize these complex workflows into a manageable and reusable pipelines. So we do not need to write so much of integration code here. It will be very easy when we'll be using the LangChain. Okay, so for modern versions of the LangChain, so LangChain is, as AI is enhancing every day, same way LangChain is also evolving every day. So modern versions of the LangChain use Runnables to build the workflows, and chains are still important concept here because they introduce the idea of connecting multiple AI operations together. Okay, so every day there will be some new concept will be coming in LangChain as well, because this is also an evolving framework. Okay, so once we will understand this concept, LangChain will provide a different implementation, just like as simple chain or sequential change, to build all these workflows. Okay, so simple chain means we'll call a model and we'll have a prompt template for that model. That is a simple chain. Okay, we are going to call a model and we'll have a prompt with us. And now simple sequential chain, this, what this will do is it will use the output of the one function as the input for the next function. Just now we discuss, right? We'll give a input, and when we'll be getting output from the first step, that will be the input for the next step. Same way simple sequential chain is working. It will use the output of the one function as the input for the next function. Okay, so each function will get the different tools or models or prompt or different parameters will be there for each of the steps. It's not like for all the operation we will have same input and output. Each step will have different input and different output. So here it's mentioned, right? Sequence or orchestrate calls to models, tools, or other component to solve a complex task. Now we'll go for the vector database. So we already know once that embedding is done. So when we are going to store that data into the vector DB, we have to do the embedding. So once that embedding is done and it is generated, then we have to store that data to the vector DB. So for that we are using the vector DB. For vector DB we have chroma DB, pinecone. These are the vector DBs which we can use. So when we have embedding data, after that we can store that embedding data into the vector DB. And this is a DB where we are not storing how we can see in the Oracle DB or MongoDB. So that is not a similar case or not a same thing. Here we are storing the numerical vectors and it will perform some similarity search to find the most relevant information from the DB. So it is not behaving like a Oracle DB or MongoDB. This is a different from the Oracle and MongoDB. So here it is storing the numerical vectors. Okay, and this just we mentioned, right? It will not go and search for the exact keyword. Okay, it will go and search for based on the meanings. According to the meanings we'll get the data output from the vector DB. Okay, now if we'll see here, it also mentioned store and retrieve vector embedding to enable semantic search. Semantic search means similar meaning kind of word or document will be getting over here. Okay, over a large amount of data. Now we'll go for the memory management. So LLMs by default, they do not have any memory. They'll not be able to remember the long term data whatever we shared with the LLMs. So it what it will do is, if we'll open one chat, it will have that memory and it will remember that. Or maybe if that chat is long, then it will forget. It just know from the between till the end, but from starting where it start, maybe it will forget. So for that, LangChain solve this problem with adding the memory modules here. Okay, so it will maintain context from the past interaction, and it will enable the better response, because now that LLMs have the previous information as well, so it will help to get the response. Okay, so and it will have some multi step task as well. So for each new prompt in the LLM, what we are going to provide it the relevant past information is already retrieved from the memory. When we'll provide a prompt, we'll get that existing data from the memories, and it will include the context as well, because from the last chat, whatever the data is there, we'll get it easily using the LangChain. So the LLMs will have that information now. With the prompt, they know, okay, there is some previous conversation as well here. So this will enable a AI application to carry a natural or context aware conversation across the multiple interaction. Okay, so if we'll see here, it mentioned store conversation history and context to maintain state and provide consistent interaction. Okay, now we'll go for the agents. Agents means we can build the agent. Okay, we can build a agent using the LangChain. LangChain have that functionality as well. Now, agents are the LLM driven components who is going to take the actions, just like as calling tools or any APIs. So if we'll talk about agents, as of now, if we'll just ask a chat GPT or any GPTs, we'll go and we'll ask a prompt, what is the fare for the flight? Okay, you'll provide the destination and you'll mention everything. Okay, you want to go from India to US or some other countries, we'll mention it and we'll get the details. It will go and search the Google and or some other websites. Will get the output for that and we'll know the fare, but it cannot go and take actions on behalf of us. It will not go and book a flight for us. So agents are like, these are the components who are going to take our actions, and just like as it will go and call a tool. So if we have that functionality or we have agents, if we'll provide a prompt and we'll ask, can you go and book a flight from India to US for the amount maybe 6,000 to 12,000 range. Okay, if we'll provide it, it will go and search the flight which is in our range and which is in our time zone, and according to that it will book a flight. So it is going to take a action, or it is going to call a external websites for us, okay, tools or APIs. And unlike a fixed workflow, an agent decide its next action. We are not going to ask, okay, do it, go and book the flight. It is automatically going and booking a flight for us, and this is dynamically. When we'll ask a question or when we'll provide a request, it will dynamically go and ask or go and book the flights for us. Okay, so for example, another example, if we'll ask what is the current weather, so here the agent is going to decide whether it have to call the API or it already gathered that data. Okay, or if we'll be asking what is the stock price, it will go and maybe call a financial API. Okay, instead of calling the weather API, it will go and call the financial API. So it's like agents are taking the action in place of we'll mention it ki okay, this is a prompt, go and call the financial APIs, go and call the climate APIs. So these agents are taking action in place of we'll be informing it or we'll be mentioning it. Okay, so chains will be follows a predefined steps. What are the steps is mentioned over there, it will just follow. And whereas these agents, what it will do is it will decide the steps at the runtime. When it is running at that point of time, it will go and decide according to our problem. It will go and decide what it have to solve. According to that, it will go and take a action, and it will call any APIs, or it will call any DB, and it will fetch the information. So according to our requirement or our problem, it will go and call the API or take any actions. Okay, so it is mentioned here, LLM powered decision makers that can choose actions, use tools, and accomplish goal autonomously. We don't need to interfere over here. Okay, now we understand these are the responsibility of each or individual component over here, but in the real application, these application are not working separately. They'll combine or they'll work together. So the next question is, how do they are going to collaborate with each other, or how do they are collaborating to process a user request? Okay, what are the prompt we are sending, how it is going to collaborate over here. So we are going to understand the how the LangChain components work together. Whenever a user will interact with the LLM powered application, LangChain is an orchestrator here. It will follow a sequence of a step before going to the large language model or generate the final responses. So instead of directly we'll send the user prompt to the LLM, what it will do is will follow a few sequence of steps, and at the end they'll coordinate with each other with different components, and they'll prepare the input for the LLM, and it will retrieve some additional information if anything is required from the vector DB or from some endpoint. It will retrieve all the information, and then it will go and invoke the large language models. So the exact workflows here, so now we are seeing this workflow, but this exact workflow, they are dependent on the application requirement. So if we don't, in our application maybe we don't need vector DB, so we'll not use this. In few of the cases we don't need memory, so we do not use it. In some cases we do not need output parsing. So like this, whatever the components we do not want, so we'll not use it. It depends on application to application. Okay, for example, a simple chatbot may use only a few components, while if we're going for the RAG application or any AI agents, they'll use the many more. Okay, so it depends on application to application. So this workflow, this is demonstrating how the major LangChain components work together. Okay, so it's not like that we'll use it. Maybe if we'll remove memory section here, the prompt template will go to the retrieve external information directly. Okay, so we can skip any of the components which we do not need for our application. So first step here is user. Okay, so user will ask a user query, so we'll go for the user query. So here, from here, the this workflow will start when we'll put a prompt, or if we'll ask any question, or we'll submit a question or request to the application. For example, summarize my resume, or what is my company's leave policy. These are the questions. If we'll provide these queries, then it will go for the prompt template. Prompt template means there are already existing templates are there, and whatever the query we asked, it will combine with the predefined instruction that is already available. Okay, and this will help us to create a well structured prompt for the LLM. So we have user query, and we'll be using a prompt template which will help us to generate a proper prompt, and then it will send to the memory. Here this is a memory is a optional, but this is a conversational history as we discussed already. So we came from user query till prompt template, and then that memory part will come. Okay, so in memory, if the application is conversational, if we need that conversation, then we are going to use it. So LangChain will go and retrieve that information or conversation history using this memory, and this will allow the LLM to generate a response based on the previous interactions. What are the interaction we had, according to that it will go and generate the responses. If there is, suppose if that application is not needed any previous conversation or previous memory, then this part will be skipped once. Okay, then retrieve external information. So this is going one by one. First we'll have user query, then we'll have prompt template. Now prompt template is there, and according to that our query or problem, it will go to the memory and see what are the histories there regarding the question or query, whatever the user asked. Okay, and then it will go for the retrieve external information, means it will go for the vector database. This is again a optional one. If user will ask some question and it will require an external knowledge base, then LangChain will go and retrieve that information or invoke that information from the vector database, and the retriever searches a vector database which will contain tons of documents. Okay, and their embedding is done, so it will go and fetch the most similar document from the or chunk from the vector db. For example, just we asked, right, what is my company leave policy? So according to that it will go and it will search for the company documents or any pdfs in the knowledge base. Okay, any internal documents where it will go and get the company policies or any research paper of that company or any external information. Here it's not required, so this will escape. But if we don't need it, we'll skip it. But if we needed to know about the any policies and all, we need to go and search for the vector db. At the end we are going to construct the final prompt, because we have users query, then prompt template help us to build a no, generic prompt, and then from the memory will what are the conversational history we needed, we already get that data from the memory. And if that vector db is needed or any data we need from the internal sources, we are going to the document embedding and we'll search here, we'll do the semantic search and we'll retrieve that information. So all the information we have. Okay, so now we are going to construct the prompt. So what LangChain will do is, the user's query, what are the document data we retrieved from the vector db, if anything is available and conversation history is available or any system instructions is available, this will go and form a final prompt for us, and then it will send that to the LLM models. Okay, there are other many LLM models, as we discussed. We can use any one of them according to our requirement. Okay, so that final prompt is sent to the selected language models. What are the model we selected from this? It will go to that model, and that model will analyze that prompt and generate a response for us. Okay, then what output parser will do? It will have JSON list table. What if the application or if the user expects that a structured response or in any format, so just like a JSON list table, so LangChain will use an any output format or output parser. It will convert the LLM's output to the JSON list or any tables. Okay, if plain text is sufficient, then it will skip this option. That's why it is optional. Okay, and then it will return the response. It will go and return the response to the user. So user will have that information, and he or she got the response. So here we'll go and notice it. Every application, as we already mentioned, every application will not use all the components. Okay, so according to our requirement, we'll go and choose the components which is specific to our use case. Okay, so next thing is prompt template. What is that dynamic prompt template means? So if we'll see here, we have candidate name. This is a dynamic prompt. Any candidate, maybe Ankita or Arpita, anything will be coming here. Okay, so candidate name will be change, or that is a dynamic one. And then resume, here resume is also dynamic. It depends on person to person, that everyone's resume will not be same, so this will also be a dynamic part. Then job role is also a dynamic part here. So for example, if we want to send this candidate name Ankita, this is dynamic. Then resume, some resume file will provide it. Then job role, Java developer or UI developer, like this we can change it. So this is the dynamic prompt template. So we'll have templates and we just need to provide the dynamic data over there. And next topic is LangChain ecosystem. So we'll not go in the depth, we'll just see high level. Okay, so LangChain is a core framework here. As our application will become more advanced, it will provide or enhance some additional tools as well. Then lang graphs we are using to build a stateful AI agents and multi agents workflows as well. Okay, then langsmith we are using for the debugging, tracing or testing or monitoring any LangChain applications. Then langser, this will be using for the deploying the LangChain application, just like as how we are deploying the REST API, same way we are going to deploy the LangChain applications as well. So for that we are going to use the Langser. This is also again a optional part. Okay, so in the next video we'll move from the theory to the practical one. So in the next video we are going to see the real world application, how it will be using, and will enhance our resume application. Okay, so until the next time, keep learning, keep building and growing. I'll see you in the next lecture. Thank you.